matrix times a vector. Inner product interpretation. Rule: the ith element of y, the ith element of y is the dot product of the ith row. This is the ith row of w with x. W with x, ith row. Rule: the ith element of y is the dot product of the ith row of w with x. Y ith row, ith element of y. Then how we will inner product y1 w11 w12 up to w1n with x1 x2 up to xn, like this. y2 up to y. Matrix times a vector. Outer product interpretation. w11 we can say w vector 1, that is the product is a weighted sum of the columns of w. This one. Weighted by the entries of x. w1 vector of x. Like this. x1 w1. We can say this one w1. This one w2. The product is a weighted. The product is a weighted sum of the columns of w weighted by the entries of x. Entries of x. x1 w1 this one. x1 w2 this one. xn wn. xn wn. This is wn. Example of the outer product method. Example of the outer product method. The product is a weighted sum of the columns of w weighted by the entries of x. Example of the outer product method. Example of the outer product method. Zero, 3, 2, 1. 2 cross 2 column matrix. 2 rows, single column, one column. Sorry. So is our outer product. Outer product, how will product 2. So 0, everything 0. So leave it. 2 of sorry, 2, this 2, and then 0 2, 0 2 plus 1 3 1, these 2, these 2, this 0 2, this 1 plus 1, this 1 into this is the, yeah, equal to 2 cross 2, 2 cross 2, 0, 2 1 2, 4, 1 3 3, 1 1 1, 0 plus 3 3, 4 1 plus 5 5. Note different combination of the columns, different combination of the columns. Which one? This, this. Of M can give you any vector in the plane. 3 5. 1. This is the what? 0 2 3 1. Here 2 1. 2 1. That's all. So vector plane, this one 3 5 available. We say the columns of M span the plane. Rank of a matrix. Rank of a matrix. Matrix rank. What is that? Are the special matrix whose columns do not span the full plane. Whose columns don't span the full plane. That is 1 2 1 2 1 column this one 1 2 1 this one 1 this one 2 1 minus 2 minus 4 minus 2 this is minus 2 this is minus 4 this is 1 this is 2. We can only get vectors along the 1 and 2. They are only vector we are getting. Direction, that is output lie in one dimension. Output lie in one dimension. So we call the matrix rank 1. Here only, here is not accept this one only. So outputs lie in one dimension. So we call the matrix rank 1. Example 2-layer linear network. 2-layer linear network. Two layer. This is one layer. This is the second layer. Okay. So xj is the one layer. Y sorry yes yi is the one layer. W is the weightage. So y equal to what? xj into wij equal to yi. Wj is the connection strength, that is weight onto the neuron. yi from neuron xj, this is the neuron. This is the neuron, full neuron. Here weightage, strength. These both are multiplied, then output together. Wj is the connection strength. What is the strength? Connection strength. Here in mathematics. In neural, that is the different. Connection strength, weight onto neuron yi. This connection strength for yi from neuron. This is the neuron. This is also the neuron. In between these two neurons, weightage is the no. That one we are calculating. That's it. After here, if one layer coming, then we will calculate this plus another one weightage. Then only we will calculate. Then only we will calculate going on in the hidden layer in neural network. Example 2. Example 2 layer linear network layer. Inner product point of view. Inner product point of view. What is the response of cell Y? Yi of the second layer. What is the response of cell Yi of the second layer? Yi equal to J summation of J equal to 1 to n Wij into Xi. Wij means here how much that strength with the Xi value to be multiplied. The response is the dot product of the ith row of W with the vector X. The response is the dot product of the ith row W, ith row, this one row, ith row of the W with the vector X. Ith row of the W with the vector X. The response is the dot product of the ith row. This is the response. Second summation is different. Multiplication. Ith row of W with the vector X. Dot product response is the, this is the ith row of the, this is dot product response Wij with the Xj. Example same two-layer network outer product point of view. How does cell Xj, how does